In this first video for Chapter 6, we're going to refine how we talk about types of variables. So recall from earlier in this class, we broke our data down into either numerical or categorical data. Recall that in order to be numerical, the data set has to consist of numbers, and the average of those numbers has to have a meaning. It has to make sense. Well, numeric data can be broken down further into two distinct types. It's either discrete numerical data or it's continuous numerical data. With discrete variables, discrete numeric data, you can list or count all of the possibilities. What's even more important is that there is a clear step between each possible outcome. The number of people in a classroom is an example of a discrete variable. So in my class, I could have 22 people show up, I could have 23 people show up, I could have 24 people show up. The next possibility after 24 would be 25. There is no possibility in between 24 and 25. I can't have 24.6 people show up to class. It's either 24 or 25. There is a clear step in between these outcomes. On the other hand, with continuous variables, they can't be listed or counted because they occur over a range, and there are an infinite number of possibilities between any two outcomes. The exact amount of time it takes to complete a MyStatLab assignment is continuous. For a shorter assignment, it doesn't have to take you exactly 4 minutes and 36 seconds or 4 minutes and 37 seconds. It can be somewhere in between 36 and 37 seconds. It could be 36.3 seconds, or it could be 36.52 seconds. So you have all of these possibilities, really an infinite number of possibilities between 36 and 37 seconds, depending on how far your measuring device goes. It might be 36.455528 seconds. And we could list all of these possible decimals in between. And so those are examples of discrete and continuous variables. Let's take this a little bit further and look at 8 more possibilities and decide if they are discrete or continuous. And I'll use D for discrete and C for continuous. So the time it takes you to run a mile, that is continuous. Again, it doesn't have to take an exact number of seconds. So it might take you 8 minutes and 36 seconds to run a mile. The next day you improve, but it doesn't have to be 8 minutes and 35 seconds. It could be 8 minutes 35.5 seconds or 8 minutes 35.7 seconds. We have all of those possibilities in between those. And time is usually a continuous variable. The number of problems that I give you for homework, that's going to be discrete. I could give you 5 problems on an assignment, or 6 problems, or 7 problems, or 8 problems. But I'm probably not going to give you 8.44452 problems. That doesn't make any sense. The number of shoes in your closet, that's also discrete. Hopefully that's an even number. You should have 2, 4, 6, 8, 10 shoes in your closet. The lifetime of a tire would be continuous. Doesn't matter if you measure that in time or in miles, it's going to be continuous. Your tire could last 41,200 miles, could last 41,201 miles, but there's still all of those possibilities because it doesn't have to be an exact mile before your tire goes flat. It could be 200.6 miles or 200.78 miles. The circumference of a hailstone, it's also continuous. Could be 2.54 centimeters, 3.08 centimeters. It doesn't have to be exactly 2 centimeters or exactly 3 centimeters. Same with the length of a giraffe's neck. That's also continuous. The sum when rolling 2 dice, that is discrete. We've seen this problem back in chapter 5. When you roll 2 dice and add them together, a 1 and a 1 would give you a 2, 1 and a 2 would give you 3, 4, and this would go all the way up to 11 and 12. There are no possibilities in between 2 and 3. You either get a 2 or you get a 3. You can't get a 2.5. Final one, the amount of money in someone's purse, that is discrete. Now, there are decimals involved, and that's a common misconception that if it's whole numbers, it's continuous. If your data consists of, if it's whole numbers, it's discrete. If there are decimals, it's continuous. However, let's say somebody has $21.37 in their purse. The next possibility would be $21.38. I can't have $21.37.5. Doesn't work. You can't cut a penny in half and make it a half cent. It's either 37 cents or 38 cents. The next possibility would be $21.39. And it would just go up from there.